Great. Okay. Since we will be connecting to an ST-Link V2 and be powered from there, we're going to need an 8-pin header. Preferably a surface mount part. So this is where we'll be running our project, specifically the 5-volt rail. And if we take a look at the ST-Link V2 schematic, we will see this is the ST-Link MCU. This is what it'll be using to drive the functionality. Here's the USB, which will be connected. Here's the header. So you'll plug this part into the computer, and what will come out of here will go to your board. We have a little power section here. Looks like an LDO that takes 5 volts and gets you 3.3. So we will be driving our microcontroller on the 5 volts here, and we will also use some kind of power circuitry to bring it down to 3.3. So let's find ourselves a header. 8-pin header SMD. So we're looking for 8. Something like this. It's in DigiKey. There's 3000 in stock. This is perfect. I typed in con_02x05. You can go with the pinouts, going counterclockwise, odd, even. I'll just go with top button, and let's put this in our coordinate. Let's map the pinouts. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's double click the symbol. Let's edit the symbol. Let's expand this. There we go. Gives us some space to put some text here. So, what do we have? We have RST. It's going to be our first one. Then we have SW clock. Then we have SWIM. We have SWDIO. We have ground. Copy, paste this. We have 3.3 and 5. Great. We might even make this smaller. That's reasonable. And let's center this component a little bit better. Maybe even raise it up 1 notch. Excellent. Let's save these changes. These are only our project, very project specific changes. This does not alter the part in or the symbol in the library, just for us. So this helps us kind of see what we're connecting. So we're going to need a power stage here that'll go into the VDD pin. So we can't just feed it in with 5 volts. If we go back to the datasheet, usually it's under electrical characteristics. We shall find VDD is a maximum of 4. So we have to bring it down to 3.3. While we're looking at the electrical characteristic, let's take a look at the power that we might require. So the current into VDD is roughly maximum 100 milliamps. That doesn't mean that is what we're going to use. Let me actually go down to the operating characteristics. Where are the currents? So let's calculate how much current we'll need. Let's have 100 milliamps minimum. So any pin is going to take roughly 15 to 20 milliamps. So that's important to keep track of. So it looks like the maximum we can draw is 100 milliamps. So we need to be careful we don't overload the microcontroller. So we can only use maximum of 20 milliamps on 5 pins, that is then. So let's find a 150 milliamp power circuit. There's almost a million of them in stock. AP2120N 2.3. Let's take a look at the datasheet. Very simple pinouts, nothing too complicated. Output voltage. Okay, great. That's not a big ripple at all. It's excellent. The input voltage is fine. It's under 6, so that's great. The output current is 150 milliamps. This is excellent. Let's hope that they do have this in the library. Otherwise, we can just build it in the symbol editor. This might be the footprint that we're looking for. SOT23, suggested pad layout. Yes, so it does exist. This is a 300 milliamp. Hopefully they will fit on the same footprint. We can double check that. So I will double click here, and here's the footprint. So this is what we need to take a look at. And here is our measuring tool. So from this point to this point is 1.9 millimeters. And let's take a look at the data sheet. The distance between these two, 1.9. Yes. What else can we measure? Okay, 0.3. Yes. And we can measure the distance there as well, which is 1.2, 1.3 here. So this footprint looks fine. This distance is the same. This distance is the same. So we've double checked the footprint. Looks good. Now we just have to wire this component. So is it possible to flip this? Let me try. Control Y, no. R, yes, it's rotating. Great, that's what I wanted. I wanted to rotate it. So by pressing X, I actually flip it across the Y axis. And by pressing Y, I'm flipping it across the X axis. And the reason why I did that is because I want the 5 volts to go into the in pin and then V out to naturally come out of the other side towards the MCU. Okay, so I'm having a trouble targeting. Even if I press W, which is the wiring tool, it doesn't connect onto the pin at all. So that's a grid issue. So we need to fix that. So I'm going to edit the symbol, and I'm going to see what the grid is here. Yeah, the grid is wonky here in the symbol editor. So I'm going to, it's off sync with the grid a little bit. You can even delete those little things. Don't need that. And let me select all those pins and let's just move them a little bit to get them onto the grid. There we go. Okay, there we go. Let's save this. Okay, there we go. Now we have a connection. Yeah, the symbol got out of sync with the grid, so we weren't able to select it. But now everything seems to be in order. But before we wire anything, let's take a look at the datasheet, specifically the typical application. Here we see something. Ceramic capacitors are recommended. Let's put 1 micro on both sides. So in KiCAD, you can click on the add symbol button, and in this category you can click on device and you will get a generic capacitor symbol, which we can later choose footprint for. So it doesn't have a footprint specified, which is okay. We just need a generic capacitor value. There's a generic inductor value, LEDs, transistors. We just need a capacitor. Put it on each side, copy, paste, and we cannot connect. Okay, so let's double click, edit the symbol. We might even have to move the pin around to get it to snap into a specific grid we want. Okay, then we save. Yes, now we can connect. Great. Okay, we have to do the same thing with the LDO. Okay, hopefully that does it. Yes, there we go. Great. And we're gonna need a ground symbol. So add a power symbol, filter GND, and we get it right away. Hopefully this fits onto our grid right off the bat. Yes. Let me just see if this component is connected. It is. Excellent. Great. That should be it. Nothing too complicated for the power management there. If we want, we can just lift this up a little bit. There we go. And yes, this goes to our VDD. I press W to get the wire tool, and it's out of sync. Edit the symbol. Let's select everything and basically just move it arbitrarily, and that'll have it snap onto the grid. Okay, let's save, let's try. Yes, now we have access to it. I'm not entirely sure why all my symbols are out of sync. I hope it's not like that when you're wiring, but if it is, just set the grid and then edit the component in this symbol editor. Great, so this is our power scheme. Next we have the not reset bit. So we want to pull this high, but I also want to give you the option of having some kind of slider so that we can slide it from 0 to 1. Let's take a look at that in the next lecture.